Continue the class. So in the previous class, we learned about how we are going to determine the different factors. Okay, so as I already told that generally here we are having the different sections. Okay, so we have this section B1, then A2, A3, E4, E5, D5, D6 and C7. Okay, so now in those sections we need to find out the moments. So M M stands for the moment in this table. Okay, M stands for moment, N stands for the thrust, and V, it stands for the shear force. Okay, so here in section B1, in section E4 and in section C7, we will be only having the calculation of moments. Okay, and in rest other sections, that is A2, A3, D5 and D6. So here we will have all the three components, that is the moments, the thrust and the shear force. Okay, so now how we need to calculate the moment and the shear force and the thrust over here. Okay, so here you can see a table has been developed. Okay, a table. I hope this table is visible to all of you. Okay, so a table has been developed for the different load cases. Okay, so case 2, case 3, case 4, case 5, case 6 and A and B. Okay, so what is this case, different cases? So the different cases are this one. So for the first cases, if the load which is acting on the top of the box culvert, if it is in the form of a concentrated load, then we need to take the load case 1. Okay, if it is in the form of a UDL, we will take consider case 2. If it is in the if okay, now the third case, the it is about the weight of the vertical sidewall. Okay, so next, the fourth case is the intensity of water pressure. The fifth case is the pressure, vertical soil pressure on the side faces. Okay, or the soil pressure on the vertical side walls. Okay, next one, this one is the uh, surcharge due to dead load and live load. Okay, so this case 6a, here the case 6a, it is for the first one, that is what we have calculated here. Okay, here you can see. So the first one is for the dead load and live load surcharge. Okay, and the second one is for only the dead load surcharge. Okay, both these two are for the dead load surcharge. Okay, so now let us find out this value. And okay, one more thing. So here we already know that this value or this L by H. So all these coefficients here, they depend on the L by H value. Okay, so in our current problem, the L by H value, it is 3.3 by 3.3, so it becomes 1:1. Okay, so that's why we need to consider all these coefficients for the section B1, A2, A3, E4, D5, D6 and C7. Okay, so I hope that part is clear to you. So let me remove everything and let us see how these values came. So these values I taught in the offline class yesterday. Okay, so how these values have come? Okay, now, so I'm also erasing these values. Okay, so I'll just show you one or two cases, and then you can understand this one. So how we are calculating and all. Okay, so Let us take the first one. That is the case 2. Okay, or the section B1. Okay, so in section B1, we are going to consider the case 2. Okay, so in case 2, we have it is WL square. Okay, so here it is WL square. The moment is calculated by the formula WL square, and here we need to multiply the factor as 0.83. Okay, so what will be this value? So this value will be, it is, see, it is plus 0.83, so 0.083 into, what is the load over here for case 2? That is the total dead load, it is coming as or total load, it is coming as 70 into L square. It is L square, means the length is 3.3 square. Okay, so if you calculate that, it will come as 63.2. Okay, now the next one, in case 3, so here we have the case 3. So in case 3, we have the coefficient is 0.021. Okay, so 0.021 into, now it is W into L. Okay, so what is the load for case 3? So what is the case 3 is the vertical sidewall. The weight of vertical sidewall is how much? What is the value of weight of vertical sidewall? The weight of vertical sidewall is 24. Okay, so 24 into 3.3 again. Okay, so that gives us the value as 1.66. Okay, so similarly, we will go to case 4. Okay, and case 4, here it is the intensity of water pressure. Okay, here you can see this one, intensity of water pressure. So in case 4, we have the value as 0.019. Okay, into the intensity of water pressure. How much we have calculated the intensity of water pressure as 33. 33 into 3.3 square. See, we are calculating the moment, so it is 3.3 square. So if you calculate this one, this value will come as 6.82. Okay, now the next one, case 5. Okay, so case 5, and we are calculating the moment. So here the coefficient is minus 0.019 into, what is the value, or the what is the load for case 5? So for case 5, the load is, what is the load for case 5? So the for case 5, the load is, it is the effect of soil pressure on the vertical sidewall. So it is 20 into L square. So it is 3.3 square. Okay, so if we calculate that value, so that value is coming as minus 4.13. Okay, so next one is case 6. Case 6. Okay, so case 6, it is the coefficient is minus 0.042 into, it is, we are calculating the moment. Here it is moment. Okay, so it is PL square. So the first case is the dead load. So, so the first one, so case X6A. So it is the uniform lateral soil pressure due to the dead load and live load surcharge. So that is coming as 21 kilonewton per meter square. So it is 21 into 3.3 square. Okay, so if you do that calculation, So yeah, this is the table. So if you do that calculation, your load it is coming as minus 9.6. Okay. Similarly, the other one is minus 0.042 into the other load which we calculated. It is 4.26 into 3.3 square. So that is coming as minus 1.92. Okay, so similarly, if you find all the values, then we will have the following table. So I hope so this uh, value you have to, or this kind of procedure you have to go on adding to it. Okay, so I'm directly taking, see here the coefficient is 0, so anything multiplied, sorry, here the coefficient is 0 and here it is 0, so anything multiplied by 0 is 0 only. Okay, so this is 0 case, this is 0, this is 0, and when you multiply this it will be minus 18.18. If you multiply this it is 11.0, it is plus 34.65, and this value is plus 6.93. Okay, now the moment for the section A2. Okay, so for that moment will be, so the first value is minus 31.6, 1.66, then 6.82, then minus 4.13, then minus 9.6, then minus 1.92. Okay, next value, that is the value of N, the thrust in section A2. Okay, so thrust in section A2 it is 0, here it is again 0, so this minus 18.18, then uh, it is plus 11.0, next minus 34.65 and minus 6.93. Next, the shear force in section A2, it is, the value is 115.5. Next we have is 0, then again I have the value as 0, then all the rest of the values are 0. You can see here. Okay, A2, the shear force is 0 0 0 0. Okay, so that's why the rest all are 0. Okay, now the moment for section A3. Okay, so it is minus 31.6, then 1.66, then 6.82, then minus 4.13, then the next value is minus 9.6, then it is minus 1.92. Okay, now the thrust value for this one is 115.5, then the next value is 0, the next value is 0 again. Okay, next is again 0, so all these values are now 0. Okay, now the thrust, yes, the thrust one, sorry, the shear force one, it is 0, then the next value is again, if I calculate, it is 0, then 18.18, then minus 11.0, then minus 34.65, then this value is minus 6.93, 6.93. Okay, now the next for section E4. Okay, so for section E4, the moment is minus 31.6, then it is minus 3.32. Next value is minus 15.45. Next value is minus 9.39. Next value is plus 19.2. Next value is 3.84. Okay. Next value is the thrust, that is 115.5. Then this is 39.6. Then the next value. So next all the values are 0 as the coefficient is 0. Okay. Now let's go to the next section. The next section is D5. So here it is minus 31.6. Here it is minus 0.317. Then it is 8.26. Then it is minus 5.0. Then minus 9.6. Then minus 1.92. Next value, that is the shear thrust. It is 115.5, 79.2. Okay. Next value is minus 36.26, and the next value is 21.9. Next I have 0 and 0 here. Okay. Next all the starting here the shear forces are 0 except this one is calculated as 34.65 and this one is 6.93. Okay, so this one is also 0. Okay, now the moment for section D6. Okay, so it is minus 31.6, then minus 8.23, then next value is minus 8.26, the next value is minus 5.0, minus 9.6, then minus 1.92. Okay, the thrust value over here is 0, 0, 0, 0, minus 34.65, and it is 6.93. Now the shear force is minus 115.5, minus 79.2, minus 36.26, plus 21.9, 0 and 0. Okay, next the moment here is 63.2. It is 11.56, 8.26, minus 5.0, and minus 9.6, and minus 1.92. Okay, now the next value is 0, 0, minus 36.26, 21.9. Next 34.65 and 6.93. Okay, so these are the corresponding values of moments and the shear force of moments, thrust and shear forces at different sections. Okay, now what is the next step? The next step is we need to find out the different loading condition, and based on the loading condition we will find out the total summation of forces. Okay, so here you can see. Okay, so let me draw the do that for you, then you will understand that. Okay, so first on so here next we will go for, that is it is the step, if I'm not wrong, it is step 4, right? Yeah, step 4. So in step 4 we need to calculate the service load design moments. Service load design moments, comma, thrusts and shear forces. Okay, so what is generally we will do, we will find out the different values of moments, thrust and shear force for different combination of loads. Okay, now the first one is the section. Okay, next we have the loading combination. Next we will have the moment, then the thrust, then the shear force. Okay, now for different sections we need to uh, combine the values and find out. Okay, now so here you may so here we will only go for the calculation of the following sections. Okay, now what are those sections? Please write down this one. The different sections are, the first section is section D6. Next section is let me write it in some other color. Okay, so it is D6, then section A2, then section B1, then section C7, and then section E4. Okay, for these sections we need to find out the different loading conditions, or we will find out the moments, thrust and shear forces based on the different loading conditions. Now let us let us recall what is this section D6, A2, B1, C7 and E4. You see, so those are the critical sections. Okay, so see here. So if I zoom in this one, so you see, so the first one is D6, then A2. Okay, so the corresponding cases we have for our sections we are considering. So first we'll consider the D6, then A2. Okay, next B1 and C7. Okay, and then we have the E4. Okay, understood? Okay, so basically it is what we are doing. We are calculating the service load and design forces which are resulting from the different combination of various cases which yield maximum moments for and forces at the supports, and the, so these are the at the supports and at the mid spans. Okay, so now let us take the different loading combinations. Okay, So first, so here we have calculated. So I hope you have written this. So here we have calculated case 2, case 3, case 4, case 5. So these different cases we will consider here. Okay. So in D6, okay. So as I told earlier, so here we will, okay, let us say D6. Okay. So here, let us say I take the combination of load case 2 plus load case 3, okay, plus load case 5, that is the intensity of soil pressure, and load case 6A. Okay, so similarly at A2 also I will take 2 plus 3 plus 5 plus 6A. I'll take this one. Okay, now in rest all the other sections, that is B1, E4, E4 and C7. Okay, so on in all these sections, rest sections, I will consider loading case 2 plus 3 plus 4 plus 5 plus 6B I will consider here. Okay, all in all these sections. Please remember that in order to get the maximum moments and shear forces. Okay, now if I add, okay, so here you add all these moments. So if you add all the moments for, see here, so here we have calculated this one. Okay, so the different cases are here. So if for this section D6, if I add all the moments and all, okay, so what value I am getting? So if I'll add all those moments, then I will get the resultant as minus 54.43, and for this one it is minus 43.67, and for this it is 65.63. Next it is 76.10, and the next value is minus 55.89. Okay, and if I talk about the thrust, it is 34.65, then minus 23.65, and it is minus 1.23. Next minus 7.43 and plus 155.1. Okay, if I talk about the shear forces, it is minus 172.8, then 115.5, then all the other values are 0. Okay, so from this we can develop one conclusion. Okay, now what is that conclusion? So based on these values, can I write like this, that the maximum positive moments develop at where? Where is the maximum positive moment? In which section we have the maximum positive moment? Huh? You can see here, this is I'm showing the section. Okay, now you see at, so maximum positive moment, the maximum positive moment is 76.1, and it is for section C7. So that is at where? It is at the center of bottom and top slab. Even here, see, here also B1. Okay, so here I can write like this, that the maximum moments develop at the center of bottom and top slabs for the condition that the sides of the culvert are not carrying live loads, and the culvert is running full with water. Okay, now this we talked about the positive moments. Okay, now let's talk about the maximum negative moments or the negative moments. Okay, now you can see here, let me change the ink, or I'll take the black ink. Okay, okay, so now see the maximum negative moment. The maximum negative moment is at E4. Okay, and where else? It is at D6. Okay, and it is at A2. Okay, so that I can write as the maximum negative moments develop at the support sections of the bottom slab for this condition. Okay, so I can write it as, so I'm erasing this one. So I can write like this, that the maximum negative moments develop at the support sections of the bottom slab for the condition. Okay, understood? So now these are the moments. Okay, so now, so we need to design these the different sections. Okay, now what are those sections we need to design? So based on these values, we need to design section C7. Let me change the ink. We need to design, sorry, again it is, or I'll just highlight it. Okay, so we need to design, sorry, the first section which we will design is section C7. Okay, then we will go for, that is the mid span of the bottom slab, this one. Okay, we need to design. Then we will design the section D6, this one, and the vertical one, that is E4. Okay, this one. So C7, D6 and E4. Okay, so if we design this, rest will be similar manner. Okay, so now let's go to the next step, that is the design of so so it is if I'm not wrong, it is step 5. If I'm not wrong, it is step 5, and the step 5 is about the design of section C7, or you may write reinforcement design of section C7. Okay, so here you can see in C7 the maximum moment is this one. Okay, so that I can write it as the service load moment, that is MW. Let's say it is 76.10 kilonewton meter. Okay, now in order to, so this is the service load moment. In order to calculate the design ultimate moment, what we need to do, so design ultimate moment equals to 1.5 into MW. So it is 1.5 into 76.10. So the ultimate uh, or design ultimate moment, or ultimate design moment, you may call whatever you want, ultimate design ultimate moment, that becomes, so it is coming as 114.15 kilonewton meter. Okay, so that is the value of the design ultimate moment. Okay, so similarly, now see here, what is the thrust value here for section C7? It is minus 7.43. Okay, so again here we will write service load thrust equals to minus 7.43 kilonewton. Okay, so since it is minus, means it is in compression or tension. It is in tension. Okay, so again, so just like the design ultimate moment, so it is design or design ultimate moment or ultimate thrust, ultimate. So here also you need to multiply minus 7 minus 7.43, so that becomes minus 11.14 kilonewton. Okay, now so we have calculated the service load, we have also calculated the design ultimate thrust. Okay, now we need to find out certain ratios. Okay, now what is that ratio? That ratio is the ratio of this one. So we need to find out NU. So this is NU and this is MU. Okay, NU into FCK by BD, that we need to find out, and we need to find out the value of MU by, sorry, just a moment. So NU by FCK into B into D, this one we need to find out, and it is MU by FCK into B into D. Okay. Right. So please tell me what is the value of NU by FCK B into D. So here B we will calculate it as per meter. So per meter means 1000 mm. Okay. Similarly, this is 1000 mm. Okay. And D. What is the value of D? D is the thickness. Okay. So that is 300, thickness of web and thickness of slab. So that is 300. And FCK, what is the value of FCK? What is the value of FCK? FCK is 20. Okay, now do the calculation and find out the value of these two ratios. How much is the value? How much is the value? What is the value? Okay, so now Bhavna, what is the value of NU by FCK into B into D? Bhavna,
Sir,
what is the value of NU by FCK into B into D? What is the value? I expect some answers from your side. What is the value of NU by FCK into B into D? Next, Harisai Teja. Harisai Teja. D Harisai Teja.
హరిసే తేజ సార్ ఇస్ కాలింగ్ పిలుస్తున్నాడ్రా మాట్లాడు.
What is the value? Next, Giri Prasad. Giri Prasad. What is the value? Next, Jagan Mohan Yadav. What is the value of Nu by FCK into B into D? Hmm? Next, Madhusri. What is the value of Nu by FCK into B into D? Next, Ismail. Ismail. No response. Next, Muni Babu. Next, Niranjan Kumar. Next, Pawan Kumar ji. 17 series, roll number 36. Pawan Kumar ji, what's the value? Next, Pawan Kumar Giraka. What is the value? Shoaib Ali Khan. Sony. Srikar Naik.
Sir, -1 into 10 to the power of -6. Sir.
Minus
6.
minus 1 into 10 to the power minus 6. Hmm? You are in final
Sir,
year and
-1 of -6, sir.
are you sure it is minus 6? Huh? Next, Srikar Naik. Srikar Naik.
Yes, sir.
What is the value of Nu by FCK into B into D? No response. Bhargav,
Sir,
what is the value?
-1.26.
Huh?
Minus minus 1.26 into 10 power 6, sir. -6.
Sure, huh?
Sir, yes, sir.
Huh?
Sir,
Next, Subama. What is the value of Nu by FCK into BD square?
Sir,
Yes.
1.3, sir. 1.3 into 10 power 6. Sir,
Hmm? What is the value?
hello, sir.
Yes. What is the value, ma'am?
Sir, 1.3 in 10 power 6. Sir.
1.3 into
1.3 in 10 power 6, sir.
10 to the power 6.
Yes, sir.
Okay. Next, Vanilla B. What is the value of Mu by FCK into B into D? B vanilla. Next, Vinod Kumar. Vinod Kumar. Vinod Kumar. What is the value? Okay. Okay, at least tell, or yeah, at least tell how we will calculate this value. Okay, if you don't know the exact value. Okay. So tell me this one. Okay, so NU is, what is the value of NU? It is this one. NU is this one, 11.14 into 10 to the power 3. This is in kilonewton, divided by FCK is 20 into B per meter I told, so it will be 1000. Then what is the value of D? D, it is again 100. As simple as that. So if that is the case, then what is the value? At least calculate and tell. It is 0.0018567. Okay. Now the next value, it is the design ultimate moment is 114. Okay. So 114. So 114.15 into, and since this is in kilonewton meter, so into 10 to the power 6 divided by 20 into 1000 into 300. So please calculate what is this one, what is this value, at least.
19.025, sir.
What?
19.025.
Sony, is it the correct answer?
Yes, sir. 19.025, sir. Sir, 19.025.
Now calculate. It is BD square. Calculate what is the value. It should come as 0.06342. Okay, now these ratios we need in order to find out what we need to find out the reinforcement details, which we will learn in the next class. Okay.